Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge 4th question, and this is marked as the difficulty as hard. And this question, build a matrix with conditions. So first let's read out this question, and after that I'll explain you that how from this question we get to know that which sort of algorithm is required to be used in it. And before proceeding with the question, I'll explain you that how that algorithm works. And then after that, I'll explain you that how we are going to do the coding part, and before coding only, I'll explain you that how we are required to come up with the coding solution. And then at the end, I'll show you that how the coding of this particular question be like. So let's get started. Build a matrix with conditions. So in this question, we are given with a positive integer k. You are also given with a 2D integer array row condition of size n, where row condition of I is basically above I and below I. Okay, so because rows are above and below, right? So that's why at a particular point we would be given with two indices. Basically not the indices, but you can say the two nodes would be given, and those two nodes would be in that manner. That first one would be that node which is above, and the below I would be that node which is below that previous node. So this is the condition, and the column condition is such that it would be of size m, which will represent that basically total m columns should be there, and then column condition of I equals to left of I comma right of I, which will simply represent that left of I and right of I which are being given to us. So in that manner we are required to make a matrix. So this is it. Here we are basically given with a lot of conditions, and according to those conditions only we are required to format matrix. So like that only we are required to check that in these conditions only are there some sort of cycle or not. That also we are required to keep in mind, and according to that we will go ahead with the solution. And then the two arrays contain integer from 1 to k. So that simply means whatsoever conditions are there, that this should be before this, that should be before that, or this should be above that, or that should be below that, and so on. But one thing is for sure, that there are total 1 to k integers in both of these arrays. That's the thing. And then you have to build a k cross k matrix that contains each of the numbers from 1 to k exactly once. So whatsoever conditions are being given, but in the whole matrix there should be only one time occurrence of a particular integer. That's the thing, and all other remaining cells would be 0. And the matrix should also satisfy the following conditions. So the first condition is the number above I should appear in a row that is strictly above the row at which number below I appears from 0 to n minus 1. This simply means that if we are given with just one condition, and in that one row condition, basically in this, if we say that we are given just one row condition, in that row condition if we are given with that above I below I only one, so the thing is that whatsoever number would be written in the above I, it should be at the above, and the below I should be below. So that's the thing which it simply means. And same goes for the column, but in that it would be left and right. So this is the thing. So here we are required to return any matrix that satisfies the condition if answer exists, and if answer doesn't exist, then we are required to return empty matrix. So the condition when answer won't exist would be in that criteria, then row condition, column condition makes a graph which will be in cyclic form. So in that condition only our matrix would be empty, else our answer would exist. And as they say that we need to return any matrix, so this simply means that we can form a graph where we can directly traverse that particular graph, and wherever these conditions satisfy, there that particular graph, that particular matrix we will be forming after that graph, and that we will be returning. And how multiple answers exist, that I will also show in the example which I am going to explain. And in this, when empty matrix would be there, basically cycles would be there in a graph, then in that case only empty matrix would be there. And why on the cycle empty matrix would be there? The reason for that thing is that, see, if we are having here we are in 3, 1 and 2, right? if there is some condition that 3 comes before 1, right, and 2 comes before 1, it's alright, but there is one more number, say 4, and that comes before 3. Let me draw it. So basically, let us say that we are having a condition in which here, say here we are having just, let us take that we are having 4 columns. Yeah. So in some condition we are given 3 is here, right, and 1 is here, right, and 4 is also here, and say 2 is also there. So but 2 comes up before both of them, right, and here it is in this manner, but it says that 1 also comes before 2, right, but here the condition is that 2 is basically coming before 3 and 4, and 1 is coming before 2, and 1 is also coming, and 1 is coming after 3 and 4, right. So this simply makes up a cycle only, right. So this sort of cycle that 1 is going to 2, and then 2 is going to 3, and then 3 is going to 1. To be clear, it is something like this, and then again to this, right, and same cycle comes up in this particular other one also. Then 2 is here, then 4 is here, then 1 is here, basically this one, then this one, and this again this one. These are forming a cycle, right. So in this condition, where you will position this one, basically this one, either you can position it before 2, or you can position it just after 3 and 4, right, but that won't be a possibility. So that's why in this particular case we will return empty matrix. So that is the thing they want to say. So this was that condition, means invalid case in which we are required to return empty matrix, and the valid case with multiple answers that I am now going to show. So let us move to that particular thing. So here's the thing. Yeah. So in this, I'll explain you later that how it is topological sort. Basically, this is a question of topological sort only, in which basically that topological sort is used on DAG, that is directed acyclic graph, in which we are required to detect that are there any cycles or not. If there is no cycle, then we will be returning our answer. If there is cycle, then we will be returning empty matrix. So from here only, you would have now known that how we are required to do this question if you have done topological sort before. Then if you have not done it before, then from today you will know that how we are required to do topological sort question. So see, in the question we are given with one K, that I have already explained that what K is exactly, and we are given with a row condition. So row condition there is given as, means I am taking this first example only, 1, 2 and then 3 and 2, right. So this particular vector simply represents that this would be above I and this would be below I, and I here represents 0 because this is particular 0 and this particular is 1, right. So here this simply means that 1 should appear above the row of this 2, and this simply means that 3 should appear above the row of 2. So that's the thing, and that is the row condition being given to us. So out of this row condition, how the graph would be formed? So graph would be being formed like this, because 3 is pointing towards 2, so 3 is directing towards 2, and then 1 is pointing towards 2, so 1 is directed towards 2, like this we will be forming a graph. And you can clearly see it is not a cyclic graph, it is acyclic graph, and it is a directed one, right. So from this we will be able to come up with a topological sort, means after forming the graph then we will perform a topological sort, and after performing this topological sort on this, our array would be like this, right, or it could be like this also. How the thing is, see how we are required to do topological sort is, first we are required to construct the graph that we have done in this particular, right, and then second thing is that we are required to push all the in degree equals to 0. You can see that 3's in degree is 0, right, its out degree is 1 but in degree 0, right. In degree simply refers to all the directed, you can say directed edges coming towards a particular node, so that represents in degree, that is coming inwards. So you can see that in degree of 3 is basically 0, right, but out degree is 1, that you can see, but here we are not concerned with out degree, we are only concerned with in degree. So in degree of 3 is basically 1. 0. That is 0 here. And in degree of 1 is also 0, right? So the second step here is, after construction of graph, for performing topological sort, what we would be doing is, we'll push all the in degree equals to 0 nodes in our queue, because this topological sort is basically doing DFS on a particular graph. So that's why we are taking here queue. And then one more thing just there is, because topological sort is one sort of is basically one algorithm, a standard algorithm, but this standard algorithm is basically found out of DFS only. So in this particular, what we are basically doing is, we are performing DFS only, and on that DFS some steps are being modified so that it could become a topological sort, and it is also one of the variation of Kahn's algorithm only. So that's how topological sort comes into picture. But that is presently not much of a concern, but just for knowledge only I'm saying. And let's go ahead with this topological sort. So in this topological sort, we are required to push all the in degree equals to 0 nodes in a queue, right? That would be done. So that's how we are forming. Here, either we can push 3 first, right? Like the way I put in this particular. So that because of these things only, means either this vector would be formed or this vector would be formed. So because of this only 2 types of matrix could be formed. So that's what in the question they were saying, that any answer you get return. So when we push 1 as the first, means 1 with in degree 0 first, and then 3 with in degree 0, and then 2 would be pushed. This 2 would be pushed then only when its in degree becomes 0. So basically the way we will be performing this topological sort, at the end 2's in degree would also become 0 only. That I'll show you in the code. So it would be much clear, but the thing is that 2 is only pushed when its in degree becomes 0. So that is the thing. And if we do topological sort from this 3, then 3 is first pushed, then 1 is then pushed, and then 2 is being pushed. So because of this, the matrix would be formed in this manner. So after pushing the in degrees, right, we get this, and then we at the end we will be checking that if listed node is equal to the number of conditions or not. So that's the thing we will be checking at the end, and if it is equal to the number of conditions, then we will be directly returning whatever vector we have formed, that is either this vector or this vector, that we will be returning. And if basically listed node is not equal to the number of conditions, then we will be returning empty matrix. So that's the thing which we are required to do, and that is also as per the question. In the question also they have mentioned that either we have to return the answer, we have to return the empty string. So this is all which correspond to topological sort, and that's why I was saying that I'll explain you that how this topological sort correspond to this particular question. And now comes the part for our column. So in column we are given with this. This simply represents this is the left and this is the right. So this simply means that 2 should appear just before, means just leftward to the 1, and 3 should appear leftward to the 2. So that's the thing here. And the graph would be formed that 3 is pointing towards 2, so it is like this, and then 2 is pointing towards 1, so this is like this, right? And the topological sort would be that 3's in degree is basically 0, right? So that's why it would be pushed first, and 2's in degree here is 1. So after performing topological sort, our in degree for the 2 will also become 0, then it would be pushed, and the in degree of 1, then it becomes 0, then it will be pushed. So that's why according to that, the column indices would be 0, 1 and 2. So basically 3 would be posted at the column 0, 2 would be posted at the column 1, and 1 would be posted at the column 2. So that is the thing which we will be doing. So according to that only 2 types of matrix could be formed. From this particular answer, our indices would be 1 is at the 0 row, so 1 would be at 0th row only, but 1 is basically at the column number 2, right? So that's why it is being here. Then from this particular only, our 2 is basically at the row 2, right? Yeah, and our column for 2 is basically 1, so that's why it is at the row 2 and column 1. And then for 3, 3 is basically at the column 1 or row 1 as per this, and it is at the column 0 as per this, so it is here. But if we check for this particular vector, then you can clearly see that here 3 is basically at the row 0, so we have put a 3 at row 0, right? But the column for the 3 would be 0, so that's why we have put it here. Basically in this you can see that there is no other form of vector for column, right? So that's why column are remaining same but rows are being changed. So that is the only difference between these two. Or other way around could be there, or both way around could be there, that both could be changed. So that's why other sort of matrix could also be formed. So that's why they are saying that we are required to return either of one answer. So that's why from our answer, if this comes out or this comes out, both of them are true. So this was about the topological sort, how this question corresponds to topological sort, and how we are required to think about this topological sort. So see, these steps, basically these steps are the ones which we are required to implement in our code. So if you have done any graph question before, so you would be easily able to construct the graph, that's for sure. And then this is a simple step that how we are just required to check that after constructing our graph, whosoever nodes would be having a degree as 0, then we will be directly pushing those to our queue. This is also a simple step. And in this, visiting a child node and reducing it in degree, basically in this step only, we are traversing our graph, reducing its in degree, and then pushing that particular node to our queue if its in degree becomes 0. So this is step for which I am saying that when 2's in degree becomes 0, then only it would be pushed. Because when we were at 1, right, so its in degree was already 0. And then we would be surely going towards 2, because in the adjacency list of 1, we would be having this 2 also, right? And when this 2 is there, then its in degree, we will be reducing it, then its in degree becomes 1, right? But its in degree is 1, so that's why we won't be pushing this 2 into the queue. And then we will be proceeding ahead in our graph, and we'll check that now we are having this node 3, right? So in this node 3, as its in degree is 0, right, so it will be pushed to our vector, so that's why it got pushed. And then in the adjacency list of this 3, we will be having our 2, right? Earlier its in degree was 2, then it got reduced to 1, because while traversing for one's adjacency list, we have already decreased its in degree. But now when we will be coming at this point, then we will be reducing one more time this in degree, and now its in degree becomes 0, so that's why we are able to push this at the last. So that's how topological sort would be performed on this particular graph. And this is the thing you are required to implement in your code. Now comes the last part, that check if visitor node is equal to number of conditions. So at this particular point, your all the nodes would have been pushed, your loop would have been exited, and then at that moment only, what we are required to do is, we are required to check that whatever nodes were being pushed into our vector, we are just required to check that if the size of that vector is basically equals to the number of unique nodes which we were having. Basically, here we are having condition that we are having total k number of nodes, right? So if both of the nodes are basically equal, then we would be returning our this particular vector, else we would be returning empty vector. So this is how we are required to implement this question. If you want to pause this video, you could directly implement that question. Yeah, and after that I will show you the code walkthrough for this question, and even the time complexity and the space complexity for the question. Yeah. So before that, I also want to tell you about one thing, that a lot of students ask me about some structure sort of course where one-on-one live without session is clearance is there, one-on-one mentorship is there. So for that particular purpose, I would recommend you Newton School. So you could head over to the description for this same, and in that you will find the link for the website of the Newton School. There you can register for the course and you can find all the details. Basically, one of the best parts for the Newton School is that you don't have to pay any upfront fee. You just need to pay the fee after you are being placed, and their placement packages are 5 LPA to 40 LPA. So whenever you will be placed at any of these companies which are being given by Newton School, so after that only you are required to pay for your fees, for which you had been enrolled into the Newton School's course. So this was all for Newton School, and yeah, you can head over for details in the description. So now comes the part about our code walkthrough. So here's it. Yeah. So basically in this question, it is being started from this particular part. I've also commented so that it could become easier for you to get into that why that particular line is written. As I've already explained that how we are required to proceed for this question, so now it would be easy for you. So now these are the things which we will be checking for our for making our vector for our matrix. So this would be having all the all the numbers which are required to be there at that particular row, and in this we would be having the row number. Basically here we are storing this, here we are storing this particular part 0, 1, 2, basically indices of the row for a particular matrix that we are storing here, and in this column we are basically storing the indices of the column for a matrix. So for finding that particular, we will be calling our find order function, in which we are passing this k, which simply means that total number of numbers are this much, and row condition, basically this particular vector is visible. Okay, basically this, and in this column condition would be passed. And after getting from this, see, the thing is that in that we will be performing a topological sort. So its output would be that either we will get an empty vector or we will get the indices vector. So that's the thing. So that's why here we will be finding in degree, we will be detecting a cycle and returning the answer as per the equality of number of nodes with the condition. So that's the thing. And then after it is being returned, then we'll check if one of the row condition or column condition has a cycle. So at that particular moment only, our row array dot size would be 0 or a column array size would be 0 if it has been detected with a cycle. So that's the thing. And at that moment we will be returning empty. So here what we are having is, we are having this particular vector here which will simply represent the indices, and first index for the row and second index for the column. So here what we are doing, right, we got all the indices which are required to be formed for a matrix, and now here our result matrix, where what we would be doing is we will be having K cross K matrix. That's the thing which we are having, because here in the question also you can see basically that we are required to return K cross K matrix. This is what they are saying, right? So that's why here we are taking the size of the result as K cross K, and then we will be forming our result matrix by this. What we are doing is that for the first for a row and then for a column, what we are doing, we are going to that index, right, this particular index vector of where we are going to that. In that, first would be our row and the second would be our column, that we are pushing into the same, and then we are directly assigning I plus 1 to that particular position. And why we are assigning I plus 1? Just because of this fact, because here we are starting from I equals to 0, right? So this one is required to be added, because our K is basically from 1 to K, not from 0 to K, right, as it was mentioned. So that's why we are directly assigning like this. And at the end, we will be returning our result, which will be formed out of this. So this was the wrapper function for the same. Now comes the main function, which is here, that is performing our topological sort. So for the topological sort, what we are doing, first we are taking adjacency list of K plus 1 size, and then our in degree vector is also of K plus 1 size, and then we are basically creating the graph and counting the in degrees, so that we could use that graph and the in degree for performing our topological sort. And here we are constructing this particular graph, and then here we are directly counting the in degree for the same. And then here what we are doing is, first we are pushing all the in degree equals to 0 nodes into our queue first. The way I had explained that first 1 would be pushed, or 3 would be pushed, or 3 would be pushed, or 1 would be pushed. So like that only we are doing here. And then we are having this count and vector of int order, which will be directly at the end return that if there is no cycle. And here what we are doing, we are taking the till our queue is not empty, basically performing the BFS. In this particular, we would be having the topmost node which would be there, which is required to be processed, and then we will be popping it out from the queue, and then we would be incrementing the count, so that in order of that count only, we are able to check that are there all those total number of nodes being pushed or not. So then we will be pushing our current node to our order. This simply means that here the thing is that either we can take this count, or even we can take here as the order dot size, that will also be suffice. And here we are taking all the nodes basically on the labels which are there for our current node and decreasing it in degree. Why we are doing this? So as I had explained you for that 2 example also, that earlier 2's in degree was basically 2 only, but because of this step only we were able to push our 2 into our this particular queue, and then we were able to easily we were easily able to process. So when our in degree basically becomes equals to 0, then we are able to push that into a queue, and then at the end, if the count and k are equal, then we are required to return our order. This simply means that all the nodes have been pushed and there is no cycle there. So that's why this is the scene. Else we will be returning empty vector. So yeah, this was all for this particular question. Now comes the part for the time complexity. So basically you can see in this we are constructing this particular graph. So this matrix. So basically the time complexity for this operation is basically k into k, that is k square. And for this topological sort, the whole process which is ongoing is basically on the k nodes only, right? So in that whole process only, the maximum time complexity out of both of these comes out to be k square only. And the space complexity is also on the basis of, there is one on the basis of graph which we are forming, means adjacency list which is being there, that also takes k nodes, and in degree also takes k nodes. And then here comes the part other one is this one, k into k, right? But this is our answer, so that's why we are not considering this k into k. And then here also we are having just k nodes. So at most we can say that our time complexity and space complexity is basically, so here comes the time complexity. So time complexity of this particular question is k into k, and the space complexity for this particular question is order of k. So this was all for this particular question. If you like the explanation, please do like and subscribe to my channel. And if you have any suggestion, you could directly comment that down. And yeah, so this was all for this question. You can also share with your friends so that it would be a great support for me also. And yeah, this is accepted solution. So this was all. Thank you.